Welcome to space. In this edition, we take you to the comet Churyumov-Gerasimenko. The small robot Philae has found organic molecules on its surface. These molecules are considered to be fundamental elements of life. We'll have more on that in a moment. But first, let's get some other news from the universe.
Vediamo alcune notizie dall'universo.
A brand new family of European launchers is coming. ESA has signed contracts with Airbus Safran launchers, France's space agency, and DLV for the development of the Ariane 6 new generation launcher and the Vega C. A team at CERN in Geneva is working with the European Space Radiation Superconducting Shield project to develop a superconducting magnet. It's to protect astronauts from cosmic radiation during deep space missions. Canadian astronaut Chris Hadfield, known for his space performance of David Bowie's song Space Oddity, is to release an album in October. All of the tracks were produced while he was an International Space Station commander. The Rosetta mission has changed our vision of comets and given a new outlook on the origin of life in the universe. Let's see how.
The sunlight shines into my eyes and I feel so alive.
The ESA teams involved in the Rosetta mission are now preparing for the last part of its amazing journey. Comet Churyumov-Gerasimenko, or 67P, has recently reached the perihelion. That's the closest point to the Sun in its 6.5-year orbit. It's an important scientific step, as increasing solar energy warms the comet's frozen ices, turning them into gas and dust. To stay safe, Rosetta has been forced to move further from the comet.
When the comet becomes more quiet, when there is less dust in the coma, this also means that the orbiter can go closer to the nucleus again, and this will enhance our chances to rebuild communications with the lander.
The robot Philae, which landed on the comet 9 months ago, called Earth for the last time via its mothership Rosetta on the 9th of July.
Of course, we dream of really re-establishing contact and receiving data, science data, from the surface again. For instance, images that would show us the difference in the terrain from November to now after perihelion.
The team in charge of communications and sending commands to Philae is based here at the Lander Control Center in Cologne. We've had rare access. The team is trying to keep its chin up, remaining optimistic that there could be another signal from the robot. There are new windows of opportunity coming up until late September.
During these periods, which last around 1.5 to 2 hours, twice a day, we try to send commands to the lander to re-establish contact.
If Philae is able to pick up a signal and fire in its instruments, it will be a last chance for the lander to conduct some important tests.
Along with the scientific community, we have prepared a series of sequences to be carried out once contact is restored. We'll also attempt more complex sequences, like trying to drill, if that's possible.
The Rosetta mission has been extended by 9 months until September next year. It's hoped this will further boost the enormous amount of data that's already been collected. But time is of the essence. In the coming months, the comet will move further from the Sun. Light will decrease, meaning Rosetta and Philae's batteries can't be recharged.
If we're limiting only to try and listen for Philae, we lose so much of the science of the orbiter's mission. We need to balance everything, listening for the lander, but also doing the science that is unique now. We can't go back and do it again. We have to be in the right place at the right time to make these observations.
The analysis conducted by Philae during its descent to Chury has suggested that comets might be key to building the ingredients of life.
We found a variety of organic molecules, of organic chemistry, which now needs to be embedded in our theories of the formation of life. How could sugars, how could amino acids be formed on the Earth when these organic material, prebiotic molecules came by comets to the Earth?
Yes, we've got organic material, and these are, and it's important to highlight this and really state that these are building blocks. These are not living organisms. These are the things that go on or can go on to create life.
The ESA team that got Rosetta to its rendezvous point with the comet a year ago has already decided how to end the orbiter's mission. The mothership will somehow join its beloved lander.
For the last weeks of the mission, we intend to do a spiraling down towards the surface of the comet. So we expect to be able to fly at very close distances, well below 10 kilometers. Most likely we'll be able to take spectacular images from very close distances. And at the end, we will let the spacecraft deposit or land, if you want, or crash on the surface of the comet.
A year after Rosetta joined the orbit of Chury and 9 months after Philae landed on it, this mission has deepened knowledge and boosted the hunger for space exploration.
It's a very, very emotional aspect also to see the results of 20 years of work as they come to Earth by radio signal from the mother ship from Rosetta.
For me, even though we've been there for this long, I'm still waiting for the end of the mission, because that for me is the whole point of why we're there, is to see this entire evolution.
Rosetta has been one of the most fantastic space missions ever. From a scientific point of view, we have been exploring a world which was totally unexplored. We have seen that this mission has brought a lot of attention all over the world, has raised a lot of emotions, and this is something will remain forever in our hearts.
Time now for Astronauts Academy. This time we're looking at how space can affect the health of astronauts.
Hello, my name is Volker Dahlmann. I'm head of the Space Medicine Office. Just come in with me into the control room where we are monitoring the astronaut health. The immediate post-flight program takes roughly 21 days, 3 weeks. That is a very heavily scheduled time where medicine has the priority over everything else. Weightlessness looks very great and is fun, but of course there is no up and down. The heart muscle does not need to pump the blood upwards towards the brain. So like every muscle in our body, the heart muscle also degrades because it's not stressed that much anymore. You have to relearn again when you come back to Earth what you have reprogrammed your brain in weightlessness, and you have to reprogram it when you're coming back.
That's all from this edition of Space. Next month we'll be looking at how satellites are being used in maritime surveillance and safety. Thanks for watching. See you then.